Welcome back, and thank you very much for sticking it out through these 10 series of videos. I have to say I never thought it would take 10 set of videos just to build a bit of hardware so that I could start programming an assembler. As I say, the inspiration for running these videos was this is the board that we built back in Marconi Radar back in the early 80s, and it used an Intel 8086, and we wrote the code into these two EPROMs, and it ran the air traffic control for the UK. And I just wanted to see if I could go and build a hardware circuit and then code an assembler rather than using an online assembler or compiler. And I wanted to try to build it into two EPROMs and see if I could then run it. So thank you very much for sticking with this. So where we left, we were looking at the operation of the LCD display, and you'll see on the LCD display it's got some instructions like clear display, switching display on and off, function set, etc. So we're going to choose each one of these functions or the instructions to actually talk to the LCD. The first thing we're going to do is use the function set. So that means setting these all to 0. So these data lines to 0, setting this fifth dB5 to 1, and then setting DL, N, and F. And we're going to set those all to 1. And 1 will say we're going to use 8 bits, which is the DL. We're going to use 2 lines, which is the N. And we're going to use 5 by 10, which is the F. Then we're going to switch the display off so we can see if we're actually talking to the display, we can see it getting switched off. And that means setting this bit here to 1. We're going to set D to 0 so that it's off. We've set C to 0 so the cursor's off, and we're going to set B to 0 because we don't want it to blink. Next then we're going to clear the display, so we're going to run that instruction, and as you see you just put the zeros in and the 1, and that will clear the actual display. Then we'll need to do the entry mode set, and this is setting the cursor, and so we'll need to set that 1 to 1. We're going to set the IDs to 1, so it's going to increment, and the S to 0 because we don't want it shifting. Finally then we're going to switch the display on, and then after that we're going to write hello world. So we're going to build up these instructions, and so in the next screen we'll go on and we'll enter those into the Notepad++. So we're going to use the out instruction and the move instruction. We said before that we're going to create 2 ports, 0 and 16, and 16 in hex is 10. First of all, we're going to initialize the LCD, and so we're going to use the instructions that we saw in the last video from the datasheet. And the first instruction we're going to set is the function set. The function set is identified by setting this bit here as 1. The next bit is a DL bit, and it's set to 1, which says it's going to be 8 bits. The next bit is the N bit, and we've set that to 1, which says it's going to say 2 lines to the display. And the next bit, F, which is set to 1, says it's going to be 5 by 10. The next, we're going to switch the display off, and that's indicated by this bit being set. The next value D we've set to 0, which says display off. The next value we've set, which is C, to 0, which is cursor off. And the next value B, which is set to 0, says it's not going to blink. The next is clearing the display, and that's identified by just this last bit. What that's going to do is clear the display and set the onboard DD-RAM to address 0. The onboard DD-RAM is the RAM on board that holds the characters that are going to be displayed. The next is entry mode set, and that's identified by this bit. It's followed by 2 bits, which the ID is set to 1, which says it's going to increment, and this last bit is saying S, it's going to say no shift. So that means when characters get displayed, they're going to increment, but they're not going to shift. The next then is setting the display on. Again, this is set by this bit, indicating that it's display on. And as it's differentiated between this one here, the D is now 1, which says it's on. The C, we're saying the same as 0, which says cursor's off, and B, no blink. So we want the cursor, we don't want the cursor displayed, and we don't want the cursor blinking, obviously, because it's not going to be displayed. What we're going to do then is use this move instruction. So we're going to move to AL. This value's here. So for example, the function set or display off, and then we're going to write that content of the AL to port using this out command. And the idea is then the CPU will take that instruction, write it to the port, and that port is then connected as we did to the circuit. So it should write then this data line here, this information onto the data lines and onto the 8 data line inputs on the LCD. Then we're going to use finally the separate port, which is the port 16, which in hex is the 10, and that will set the characters. And so we'll use that. We're going to use move AL, and so we're just going to put H. Then the out instruction will actually write that value H, setting this value 1, which is the RS value, then to say it's now characters being displayed, and that will actually display the characters onto the LCD. What we have been doing is writing the actual machine code and putting the machine code into a binary file. That's not how we actually write code. We write the actual code using assembler, and we write it in ASM86 or assembler 86. And then we use a compiler to compile that, and that gives us the machine code. But I've just been writing some machine code test examples. But how I'm going to write this next piece for the hello world is by writing it in assembler ASM86 and then compiling that, and that will produce the machine code. I use an application called Notepad++. So if I do File and New in Notepad++, and then I'll do File, I'm going to save that as, I'm going to call this hello.asm, which is the assembler code. Save that. Now I'm using Notepad++ because it will show different colors when I put in the various instructions. So the first command I'm going to put in is the move AL and the out statement. So as we said, this move AL, what we're doing is we're putting in this function set. So the very first command we're going to do is move into AL this function set. So I'm going to add the actual comment at the comment line, which is a comment is made by putting a semicolon in. So I'm going to put in function set. And then we have the out command, which is writing this instruction. So this instruction will actually go then to the data lines. The B at the end is indicating binary. So you can see that's the instruction that I'm going to put in, and those are the 8 bits I'm putting in, and as it's in binary, I put in B. This port is 0, and that's indicated by the X, and that indicates that's a hex value. So that's the function set. The next one is display off. So again, it's MOV. So the move instruction, AL, and we're going to put in the 0, 0, 0, 0, and then the 1, 0, 0, 0. B to indicate binary, and then I'm going to comment that to say that that's display off. It's useful to put in comments because when somebody else comes to pick up this code, then go like, what's that supposed to do, or why is it doing that? And that's why we comment. We're going to then output that to the port 0. The next is the clear display. And that's the 00000001 binary. The next, then we're going to write that out to port the next instruction we want to pass onto the data lines and so to the LCD display is entry mode set. So it's move AL, oh sorry, and entry mode set is 00000110 binary. And again, we write that out to port 0. Oh, I've put in 0x0. I think I must have put in letter 0 there, letter O. AL. And then the last where we put the display on. So again, move that instruction. And the instruction this time is 00001100 binary. And again, we write the out instruction. The next instruction then, having done all that, is we're going to write the display. And again, it's simply just using the move instruction again. So move AL. Oh, I just realized I've forgotten the move AL there. And we put in a character. And this time we do out, but because we want to set that RS flag, that's where we're using the OX10. So that's where we're using the other port and AL. So now what's happening is it's writing to the other port, and obviously on the hardware, we've actually got that port set up to capture that 5th address. And that then should allow the H character to be displayed. It's then simply, I'm just going to copy these. I don't need this. I'm going to take these off. And then HELLO space WORLD. I'm just going to put an exclamation mark just at the end, just to complete that. So that's my Hello ASM or assembler. I'm using this Notepad++, as I say. And the reason I'm using Notepad++ is because it gives you different colors. It can show you if you've made a mistake, that where I put in that, accidentally put in the letter O instead of a 0. You saw that come up with a different color sort of to notify me. I'm putting B at the end to indicate that's binary, and these OX indicate that's hex. And so that's actually how we would write assembler code. We can write in jump statements. So if we added, say, to the top here, which we would indent, INIT, so that's a label. And we could then write down in here jump, and we could say to the label, which is, and you see it's coming up with the label jumping it. Now I'm not going to do that, but it's just showing you that's how we would actually write any assembler code. Sorry, it's JUM. JMP. Silly me. That's why it's not understanding what that was. Apologies. So the jump statement there would jump init, and that would jump up to the init statement, and it would automatically work out which jump you're actually using. Now I'm not going to do that. I'm just going to take this. So I'm just going to take that back out. But this is how we would actually write assembler. You actually write the assembler rather than doing the machine code. And after we've got this assembler file, I'm just going to save that. And this is now saved to, as it says there, C binary files hello.asm. And then I can use a compiler, and the compiler, I'll run the compiler, and the compiler will then change all of that assembly code into the binary files, into the machine code. So now that I've written my assembler code, ASM86, I now want to compile that into machine code. So how I do that is I open my command prompt. I set it to the directory where I've put my ASM file, which is binary files. Because we've saved it here to C binary files, hello.asm. And I'm using NASM. So I put in, which is my compiler. So NASM. I put in the instruction -f. I want a binary -o. I then put in the hello.bin, which is the output file I wanted to create, hello.bin. And the name of my assembler file, which is hello.asm. And by running that, that will actually create a binary file called hello.bin from ISM. If we run that, oh, there's some error. It says at line 7. 7. That's what's wrong. Let's try it again. Oh, it still says, oh, I didn't save that, did I? There we go. Okay, so if I do dir, you can see it's actually, there's my ASM file, and it's actually created my binary file, hello.bin. So I can actually view that by opening Windows PowerShell. It's actually looking at the same folder of binary files. If I dir hello.star, it again showing you the hello.asm and hello.bin. If I do format and I do hello.bin, this will then show you the binary file. And there is the binary file with all the machine codes already written in to create the machine code. And actually, if you look closely, you can see the HELLOWOR. So it actually has encoded those characters. It's actually able to read that as part of the format hex. So what's the next stage after that? Having created the binary file, we need to load that binary file then into my EPROMs. So actually, we'll need to return to the original code I wrote, where we have to then split that binary file into two parts, because we need a high byte and a low byte. So the B0, the E6, the B0, the E6 will need to go into one set of the EPROMs, and the 380008 into the other EPROM. So we'll need to go back and somehow get that binary file and get out the high and low bytes so we can create the binary files for the two EPROMs. So I'll then go to my Visual Studio and open up that file we had where we created the original binary files. So here I've gone back to my original binary file where we create the two files, the two binary files. And if you remember, we put the code in behind, and here this one is for creating the EPROM D8 to D15, and here's the bit of code we use for just creating the ones from D0 to D7. And all we were doing was we were creating a binary file and adding the code there. That was our test code. If you remember, we put the test code in of move AL, add AL, do an out, and then a jump, and our original jump. So I'm going to open that by just doing File, Open, and then open that project that we'd saved before, and that gives us our two forms. Now, what we're going to do is we're going to need to add a new button. I'm going to call that read even. And what we need to do now is write a bit of code that's actually going to go through and just read these even ones. So what I'm going to do is I'm going to go through and read each one of these bytes one at a time. So it's going to read that byte, this byte, but it's going to only want to know about the even bytes. So although it reads every single byte that goes to this binary file, it's just going to say, right, I just want the even one. So it's going to be B0. When it reads 38, it's going to ignore that. It's going to move on to the next one, which is E6. It's going to ignore the odd one and going to go on to do the next one. So it's going to read through the binary file we've created, this hello bin. It's going to read through all of those and only look at these even ones. So I'm going to add the code in here. And what I need to do is when it reads this, so when it goes through and it reads the binary file, I need to then to output that binary file so I can grab the data from that binary file. So I'm going to do that by adding a rich text box. So if we go back to the design here, go to Toolbox and go to this rich text box, and I click on this and I add that. So now if I go back to the code here, this will be even. So what I'm doing here is I've created a file name that's just a string, so a value, what I can call file name, which down here I've said, this is the file I'm reading, C binary file bin. So that's just a string to hold that file name. File length, that will actually work out how long the actual file is. So when it reads in the binary file, how long it's got to go through that. We then have to define this value called reader as a binary reader, which is a class that will actually read the binary file. I define this byte array, which will hold all the bytes. So it will hold, so what it does is it reads into this byte array every single one of the bytes. Within each one of the byte array is this small byte that we'll look at individually. I then got a couple of strings and some integers to do some counts, a value and some value of the rich text box, which we can add out. I've got this add ival, but which I'll come back to in a minute. So what the code does is it sets up the file name. It then uses the file stream to say I want to read this and open it. So it then uses this by then opening that file and using this reader, which is a binary reader. And if we look at binary reader here, you'll see it's a reader will read that file in. And in this case here, this read bytes part of the reader. So there is read bytes, as you can see there, it says it's a function called which reads the specified number of bytes from the current stream into a byte array. So all this does is this reads into this byte array here. So we've had this byte array here defined. It reads into this byte array every single one of the little bytes. And then in this loop, we go around every single one of the bytes to have a look at it. We use this value, we use this counter I to count how many times we go round. So it starts at 0, then goes round 1, 2, 3, 4. And this is where we use this modulus command. So what we're doing here is we're saying only interested in even ones. So only when we've got a value I, the mod 2 is equal to 0, then we're interested in actually getting that value and having a look at it. This little piece here, because we need 2 bytes, so whenever we get a 4, we need to actually maybe add a 0 on the front of it. So rather than it just coming in as 4, we need a 0, 4. So this is just adding any spacers on the front where we get a single value. And then this is writing it out to the rich text box. And then this is then just going around the loop again. We loop around again and loop around again. So this is just reading through every single one of the bytes in our binary file here, hello.bin, and it's saying, right, read that one, read that one, read that one, and output it to the rich text box. So it's probably easier if I run this so you can see what's happening. So if I run that and click on read even, there you'll go. It's saying its total bytes is 68, which is the length that it got there. So that's what it's doing. It's reading through and getting each one of the even ones. So all it's done is gone into that binary file here and read the B0, skipped that one, the 0, etc. So it skipped all the way through. So now the thing is that when we're going to go and add this to write out to our file, if we go back to our design here, where we're going to create, this is the one that created the file for the EPROM for the D0 to D7 range. And if we go and we look at that, there's the value there, B0 and H4. Now what we're going to do is we're going to get each one of the values from here. And it's going to say at that code position, FB, F5, write B0, and at this one here, write the E6, and at this one, write the, but I could go through all of this, but what I'm going to actually do is I'm going to get it to write that entire code out for me. So I go back into here and I click on the read even, and I take out the comments I had in string, which will actually apply that and apply that and apply that. So what I'm doing now is I've got this value here, add value, which I've set to 64501, which actually is that binary value FBF5. So what it's going to do is it's actually going to write that entire line for me. So it'll save me having to actually type that in. So if you'll see what happens if I run this now, you'll see what I mean. So now when I click on the read even, what it's actually done is it's actually written this command, which we can then just simply paste in. So now we've done the even ones. You'll see it's gone, here's what we need to do at F5, F6, F7, F8. So not only has it got the P0, it's actually written all these bits for me. So all I need to do is then copy this. Control C for copy. Go back to the files that we wanted to do here. And this is the even one. And if I just then simply put that in there, and do Control V to paste it in, it actually writes in that code for me. Okay, so whereas before I was having to type them in manually, etc., I've actually written this piece of the read even to actually write out the bytes for me there. Now if I go back and I need to do one for the odd, so if I then go back to get a button, add a button, and that's going to be read odd. Now, if we click on that, all I'm going to do is copy the entire code that we had here. Oops. Sorry, I dropped something on my keyboard there. And place this here. And this will read the odd one. So I need to change this imod to say when that modulus is actually 1. So it's actually the division. So when I divide the value I as it's counting round by 2, if it's the odd value. So again, if I run this and click on the read odd, this is now reading through and getting the odd values. So I go through, it's getting 3, 8, 0, 0, etc., etc. And not only that, it's actually writing the code that I actually need for that. So if I copy that, go back to my file here, which is creating the 8 to 15 file. And here we had put in our test code. I'll just show you here. Rather than overwrite that, I'll put this piece in here so you can see. So whereas before I was manually having to type that in, I've actually written the code read even and read odd in such a way that it actually gives me this piece in the front. I could manually go in and type this all in, but actually it obviously makes it a lot easier than that. So that's why I'm going to take that out. And so now, when I run these pieces to create my file, so now it will actually create the EPROM binary file from 8 to 15, and this one here will create the binary file for the D0 to D7. So I'll just maybe let you see that code again there. So as I say, it's just reading in the hello. It's adding in this string piece, so that will actually save me having to type that in. So it's actually typing this string out and then adding this value in here. So it's getting the value and adding it in, and that's how I'm able to actually write that entire code to save me having to type it in manually. So now if we run this and we do a create file and we do a create odd, so that now will have created in our binary folder the two files in the 8086 folder, the ROM odd and the ROM even. So if we go to here and we do CD 8086 dir, there's our two files which just created, and if we do format -hex and ROM 8086.bin, we should see just the ones for the even file. So if we scroll up to the FB, there's the even ones just put in. We've still got our jump statement at the bottom here because we never changed that. We left that in as it's always been, so we didn't touch this piece. We're only changing this piece. And again, if we go back and we type and we do dir, we can see the ROM 86 odd one. And it's similarly, if I did a format hex of that, you'd see all the odd ones. So now I have actually got the two binary files. So it's taken the original hello.bin, read that in, split that into the two separate files, and then I can use those two separate files to write to my EPROMs, put the EPROMs into the board, and then we can run that, and it should display hello world. Now that we've written our assembler file, we've then used NASM to compile that file into a single binary file. We've then used our program to split that into an even and odd, and we've looked at the binary file. We now need to just program the two binary files we've created, one for the D0 to D7 and one for the D8 to D15 EPROMs. So I use my XG Pro, and we load the files we just created, which are in binary files 8086. We'll load this file first. I'll remove the EPROMs. load that into my programmer. The EPROM is now in the programmer. I then do program. It then writes the contents of the binary file into the EPROM. It verifies it. I then click back. I then take out the EPROM. I then take my other EPROM out. Load that into the EPROM programmer. I then file and load the other one for the 8 to 15. I then program this. It verifies, and that's the second EPROM programmed. I then put this EPROM back into the board. This is the one of the D0 to D7. Just make sure that's fitted. I then take the other one that we just programmed and add that to the board. I'll now remove my EPROM programmer, put that aside, and bring in the clock and reset circuit. First of all, I need to connect the positive and negative rails in. I've got the white to positive, so make sure I put that white to positive. I have the reset signal, which will go to here, and have my clock, which I already get to, but it's way in there on that pin in there. I'm not sure if you can see that. That's into there. I then want to connect up my Arduino. I have my common ground. We're going to look at the address lines. So I'm going to connect this one to the ALE signal so I can track the address lines. I then need to connect these. What I have again is the 16 address our digital inputs, which I'm going to connect to the address lines. So starting at this brown and going through red, orange all the way through. So this needs to go to pin 2 because that's the A0 line on the address output. So that can go in there on pin 2. I'm going to use the address lines on here to connect these cables to start with a 1A2 all the way through. So I connect these in here like so. So that's going to capture the address lines. This is the A0 and there's the A1, A2, A3. The other address lines are on this side, which are a little bit more tricky to connect to, but if I connect those in, Is that not going in? That's why. Okay, so that's the other address lines connected. This last one. And so that's now all 16 address lines connected to my Arduino. I then open the Arduino, upload the sketch, compiling, uploading, start the serial monitor. There's the jump. There's it writing to port 0, port 0. So there, it's clearing the display and running through some of the initialization. And here it comes, running Hello World. Success! Finally, I'd like to say thank you all very much for following this little 10 series of videos through. And at last, we've actually got the code running and it writing Hello World, which is where I started some weeks ago. Thanks very much.